Dear students, welcome to our summer school. The Energy Efficiency in Agriculture course will enable you to form a set of knowledge to ensure a highly efficient use of machinery and equipment in agriculture, in accordance with the modern requirements of resource saving and environmental safety. As a result of mastering the discipline, a listener will learn to analyze and summarize scientific and technical information, advance domestic and foreign experience in the use of machinery and technological equipment for the livestock and crop sectors of agricultural production. Lecture 1. Energy Efficiency in Agriculture. The first lecture, Energy Efficiency as a Factor of Sustainable Agriculture Development, is devoted to the general fundamentals of energy efficiency in agriculture, as well as analysis of characteristic technological processes in the crop and livestock industries. Agriculture is becoming an increasingly sensitive system in market economic conditions. The increasing cost of energy sources requires such an approach to the assessment of mechanized technologies, which must take into account the energy efficiency of the cost of producing each type of agricultural product. The criteria that reliably determines the energy efficiency of the technologies used, not excluding cost indicators, is the minimum energy consumption per unit of production both in individual technologies and in the economy as a whole. In this regard, a new field of knowledge is being formed: energy analysis of technological processes in agricultural production, which allows to evaluate existing and planned technologies, their prospects from the point of view of energy efficiency, in comparison with those used in practice. The main task of energy analysis is to study, quantify, and optimize energy flows in agroecosystems for the purpose of farming, which would ensure the maximum use of natural and anthropogenic resources and energy by biological organisms for sustainable growth of plant and animal productivity and environmental protection. Energy consumption is the amount of energy and fuel consumption for the main and auxiliary technological processes of cultivation and agri-product production. The production of agricultural products is always based on agri-technology, with the main role played by the natural usefully consumed energy, solar energy, soil quality, atmospheric heat, and precipitation. The total energy intensity of a technology, process, complex, or system of machines is the sum of direct and embodied energy inputs related to the volume of output or work performed. Direct energy costs: energy spent on the production of products directly in this technology or enterprise. We have given an example in the cultivation of winter wheat in field operations: tillage, sowing, crop processing, harvesting, and preparing the field for the next sowing. Embodied or indirect energy costs: the energy spent on the manufacture of energy carriers, mineral fertilizers, herbicides, chemical pesticides, and the technologies of cultivation, harvesting, and post-harvest processing and storage of products. As the main criterion characterizing the energy intensity of a process, technology, or system of machines, the total energy intensity EX is taken. It represents the sum of direct and embodied energy costs related to the volume of production, where EDI, direct energy costs, on I technological process, MJ. EOI, energy costs embodied in the production of energy and other resources, power means, working machines of technological equipment, taking into account the cost of maintenance and repair of feed, raw materials, buildings and structures, storage facilities, warehouses, etc., related to the I process, MJ. B. Gross production, T. Pieces. For a comparative assessment of production processes, technologies and research and technology developments from the point of view of resource saving, it is advisable to apply the generalized KE and partial KEI criteria for energy efficiency, energy consumption coefficients, formulas 2, 3. The ratio of the energy contained in the final product to the energy spent on its production gives the bioenergy efficiency N of this production. Formula 4. Where E out, energy content of livestock products. E. Total energy consumption for livestock production. Assessment of energy consumption in agriculture. 1. Ensuring the competitiveness of Russian-made products is possible through the modernization and implementation of conservation agriculture technologies and resource conservation in animal husbandry. 2. Reduction of mechanical effects on the soil and an increase in the content of organic matter due to the constant preservation of the cover of plant matter. 3. The introduction of saving agriculture as a result of reducing energy costs for crops production, reduction of operations in the field, and, as a consequence, reduction of fuel consumption by 2.0 to 2.5 times. 4. The introduction of methods for assessing the energy consumption of technologies in crop science and animal agriculture. In crop science, energy consumption consists of the embodied energy consumption of energy machine, EEM, Formula 5, as well as the embodied costs of agricultural machinery, ESC, Formula 6. An example of the calculation of harvesting cured hay. Productivity of the production line, WH equals 5,000 kg over H of dried hay. Slide 11 shows the options for assembling aggregates, the energy costs of operations in MJ. The best options for track aggregates that perform hay harvesting operations with minimal energy are located in the table in line 8, which is also shown in the pictures when performing hay harvesting operations on slide 11. As an example of the application of energy analysis of animal agriculture, we give an example of calculating the energy content of products on a bovine farm. A diagram of the energy contents of gross output on the farm, which shows the movement of energy flows in the production of milk, is presented. Flow movement consists of the total energy content of gross output, including the energy of the produced milk, culled animals, the resulting offspring, the energy of the animals being raised, the energy of manure and litter, as well as the total energy consumption of the total energy transferred to the final production of a bovine farm. The calculated data are presented in the table, slide 13, and in the diagram, slide 14. Analysis of the table shows that the highest rates of energy expenditure are located in the total energy embodied in the cost of foddering and make up 70% of the total costs of the total energy expended. Measures to reduce the energy consumption of livestock products are as follows. 1. Optimize as much as possible the granulated feed processing line. 2. Optimize the diet of animals. 3. Introduction of resource-saving technologies for processing animal and poultry waste, with the involvement of energy and nutrients in crop technology, with the organization of organic farming. However, we will talk about this matter in more detail in our second lecture, Energy Efficiency of Modern Resource-Saving Technologies.